Okay, so to piggyback off of 1715, we could calculate Kc here. So the numerical value of Kc for this reaction can be determined from the relationship of Kp and Kc. However, this portion will not be accessed in the AP exam, so I'm just going to show you here, but I'm not going to assign any problems where you'd have to do that. Okay? Okay, so going on to 1716. Okay, moving right along. And feel free, if you want to pause the videos and try to do it beforehand, you're more than welcome to. Okay, so 1716. Okay, so Kc is 49 for the following reaction at 450. There's your reaction right here. If 1 mole of H2 and 1 mole of I2 are allowed to reach equilibrium in a 3-liter vessel, A, how many moles of I2 remain unreacted at equilibrium? B, what are the equilibrium partial pressures of H2, I2, and HI? And C, what is the total pressure in the reaction? Okay, so once again, this is going to be quite a long problem. Okay, so let's start out. Okay, so you guessed it, we are going to be doing a Rice table. Okay, it's pretty standard for equilibrium. H2 plus I2. Now all of these are gases. Okay, so writing down a few things, we know that the Kc is 49. We know our temperature is 450 degrees Celsius. Okay. Let's see, we have 1 mole of H2 in 3 liters, 1 mole of F2, and so those are going to be our initial concentration. So let me zoom in here. So our initial concentration, we would calculate, I'm going to use a different color pen here. We would do 1 mole per 3 liters. So we have a concentration of 0.333 molar. Same thing for here, you're going to get 0.33 molar. And let's zoom back out. And you start out with 0 molar of this. Okay. Now, because we know the starting concentrations, we can say that the change here, obviously we're going to go forward. We have no products, we want to produce products. We're going to subtract some value of x, some value of x. Since these coefficients are 1 and this is 2, then we're going to add some change of 2x. And so let's get our equilibrium concentrations down here. 0.3 minus x, 0.3 minus x, and then 2x. Okay, so here, just like our previous problems, we're going to now use our Kc value to determine what x is, because we want to know what the concentration is. And so 49 equals, now I'm not going to write the expression out, but I would say do that on the AP exam. Go ahead and write the expression so the AP readers know that you're able to do that. Our products go first, raise the coefficients. 0.33 minus x, 0.33 minus x. Once again, that's going to be squared. This is a perfect square, so what we can do is take the square root of both of these. Okay, what we get is 7 equals 2x over 0.33 minus x, and we can solve for there. Now, I'm not going to show you the long algebra portion of this. If you want to pause the video real quick, solve for x and see if you get the same thing. Simplifying all the way down, you should get x as 0.257. Okay, and so what we can do is go back and find the individual concentrations of H2 and I2. Since those are equal, we can express it like this. 0.33 minus x, plug in x, you would get 0.074 molar for those two. Okay, and it looks like I'm going to run out of room, so I'll have to extend the page. Solving for HI, okay, 2x equals 0.51 molar. Okay, and let me extend the page real quick. If I can remember how to. Well,